Hi, this is Professor Fernandez. We are going to work on class notes E in lesson 9. So this example asks us to calculate the determinant of this matrix. And, based on the definition that we discussed in the previous video, I'll just scroll up real quick. That is definition 9.2.2. This is the row expansion definition of the determinant. You have a choice. You can pick whichever row you want to calculate the determinant. So that being said, for this particular matrix, this is a 4 by 4 matrix, and we have therefore 4 rows that we can decide to choose from to calculate our determinant. But it would be easiest if you picked a row that has lots of zeros. Why? Because remember, like we saw in the previous video, the entries of the matrix itself enter into the determinant calculation. So if we pick a row with a lot of zeros, that will simplify our calculation. This matrix happens to have the first row and the last row with lots of zeros. So it doesn't really matter which row we'll pick. So I'll just pick the first one. All right, so I'm going to pick I equals 1 for our matrix calculation. So I'm going to go back up to the definition. Actually, I'll just read it here. And I'll say I'm going to sum from j equals 1 to n. This is a matrix with 4 columns. A sub 1, because I've picked the first row, ij minus 1 to the I plus j, determinant of mij. So that's reading off our definition of the determinant. And like I did in the previous video, I'm going to write this out first. So this is the j equals 1 term is a11 minus 1 squared, determinant m11, plus a12 minus 1 cubed, determinant m12. And one thing to note in passing, right? Notice the pattern here. Add these numbers, gives you that one, and then take these two numbers, put them in there, right? So that makes life a little easier. Plus a13 minus 1 to the 4th, determinant m13, plus a14 minus 1 to the 1 plus 4, determinant m14. Okay, and you can see here why we are going to only have to calculate really one of these 4 terms, because this term is a11 up here in the matrix. That's 1. Great. So that's 1. But every other term in the first row, a12, a13, a14, this is a12, this is a13, this is a14. So these terms are all 0. So I don't have to calculate these minors, right? They are irrelevant. They're being multiplied by 0. Great. So I'm actually going to simplify a lot of this by erasing all of that and leaving the only thing that we have to calculate. Okay, so great. So let's put in here, a11 is 1, minus 1 squared is 1. So really all I have to calculate for this determinant is the determinant of m11. And this is the matrix obtained up here in the A matrix by deleting the first row and the first column. So I'm calculating the determinant of 3, 2, 1, 2, 3, 0, 0, 1, 0. Okay. At this point, you have lots of choices. You could, for example, go back and use exactly the formula that we derived. There it is, equation 9.3. Or you could just, which is kind of the beauty of this method, you could apply the same exact method once again. The row expansion of the determinant. So I'm going to use that approach here just to illustrate this definition further. So I'm going to choose the last row. And again, because this entry is 0 and this entry is 0, those terms in the row expansion definition are not going to contribute anything. Only this one is. Okay, so that's going to save me a little bit of work. So I'm going to write that out. So this determinant is going to equal this entry, which is let's see, third row, second column, minus 1 to the 3 plus 2, determinant of m32. So a32 is 1. minus 1 to the 5th is negative 1, so I'm going to have negative determinant M32. And then here I have to go in and delete the third row and the second column. So I'm left with the determinant of 3, 1, 2, 0. And this is the point of this definition of the determinant, to eventually boil everything down to the determinant of a 2 by 2 matrix, which we can calculate fairly easily. So here I multiply the diagonals, I get 0, minus multiply the off diagonals, I get 2. So my final answer is negative 2, so that's 2. So that is the determinant of this matrix using twice the definition of the determinant, the row expansion definition.